All right, so today we are going to be talking about some of the things coming in Godot 4.3. The obligatory About Me slide. Hello, I'm David Snopek. I specialize in VR and online multiplayer. I work at W4 Games. I am a Godot maintainer on the XR and GD extension teams. I maintain a bunch of add-ons and extensions, and I make my own weird little games. More info about them at snopekgames.com. And I stream on YouTube usually every week. I'm taking a little sabbatical from that, but I'm sure I'll be back at it in a couple of weeks' time. So a quick warning up at the front. I'm going to be focusing on the stuff that I know about, either because I worked on it, or it's in an area that I'm involved in, or it's something that I'm interested in. There's probably loads of things that I'm missing. If anyone knows about other stuff in Godot 4.3 in any of the areas that we're talking about, feel free to yell it out. We can update the slides live, or talk about it at the end. But yeah, there's so much cool stuff, and I'm only aware of a portion of it. So first, some new stuff for 2D. Tile maps, which were redone heavily in Godot 4, and the new kind of version of tile maps had tile map layers within a single tile map node. The original reason for doing that was to allow for some tighter user interface. Well, the tile map contributors found a way to do that, to have the same, more efficient UI, but splitting up the layers into individual nodes, which is way more Godot-ish. There is a new Parallax 2D node. I don't know if any of you have used the Parallax layer node. I've used it in a couple of projects, and it is so confusing. I've always managed to get it to work through a lot of just trial and error and fidgeting with things. This new Parallax 2D node, which replaces it functionally, has a much different, easier to use design. I'm excited to, I haven't done a 2D project in a really long time, but I'm excited to try it eventually. In the upgrade from Godot 3 to Godot 4, there were a bunch of techniques that people commonly used for making pixel-perfect games. I put that in air quotes because everyone's definition of what pixel-perfect means is a little bit different. For a lot of people, that just means like the game world is in these small integer pixels, but you can still move the camera in the kind of like sub-pixels. It means different things to different people. But an effort was done by Adam Scott to try and look at those use cases that people were able to do in Godot 3 but couldn't do in Godot 4, and added a bunch of new options to hopefully unlock all of that stuff for Godot 4. And there is 2D physics interpolation, which basically means like making up in between frames to hopefully get smoother, less jittery 2D physics, which works really well with the pixel perfect stuff. Rendering. A lot of the things done in rendering are kind of complicated, and rendering is not my area, so I will do my best to attempt to explain, but I'm not sure I'll do that great of a job. But there's some really, really cool stuff going on in rendering. There is this acyclic render graph that Dario did. He wrote a really great blog post. I'll share the slides later, and you guys can check out the link to the blog post if you haven't seen it already. Basically, GPUs are massively parallel. Like a discrete GPU has thousands or tens of thousands of GPU cores all running at the same time. In order for different parts of your render pipeline to depend on other parts, you have to make sure that those dependencies are finished before the things that depend on them start working. And the way that is done in Vulkan and similar APIs is you make barriers. But it's really easy to get wrong when developers are making those barriers manually, either to miss a barrier that they need but didn't think that they need, and maybe it even works for them, but then like on a different GPU doesn't work, or putting in way too many barriers, which will just tank the performance of your renderer. So Dario made this acyclic render graph where basically you just say different GPU resources depend on each other, and Godot will automatically figure out where to put the barriers. This is not something that any of us will probably use directly unless you're using like the render device API. I'm probably never going to use it, but it will make the Godot renderer probably faster, probably more stable for all of us. And it was a huge undertaking to implement this, and it's very cool that it's coming for us in 4.3. Reverse Z, another sort of technical thing. Clayjon wrote a really good article about it on the Godot blog. Basically, if you store the depth buffer backwards, we get better precision in the places that we generally need it, like floating point precision. That's really all there is to it. It breaks some people's shaders, but it's a net win. You will hopefully see less Z fighting in your 3D Godot games. There is a Direct 3D 12 renderer. So now we have, it gets sort of confusing terminology-wise. We have like the forward plus renderer and the mobile renderer, which up until now have just meant Vulkan. But now either of those renderers can also optionally use DirectX instead. There is an in-progress metal renderer that will basically work the same way. You'll be able to use either the mobile or forward plus renderer, but with metal in use on Mac OS rather than Vulkan. But that's not finished yet. It's not going to make it into 4.3. Compositor Effects API. So Godot, unfortunately, still doesn't give developers a ton of control over the render pipeline. The plan is to fix that, to make it very configurable, but that's still a work in progress. One step towards that is this Compositor Effects API, which basically allows there to be a bunch of hooks during the render process where your game can just inject your own like rendering commands as one way to make things a little bit more flexible. I think it's mostly useful for like post-processing effects. I'm very interested to see what people end up making with this. The OpenGL renderer has, up until now, and I guess still now, but much less so, been missing a whole bunch of features that the Vulkan renderer had. One of those being MSAA. MSAA is one of the anti-aliasing techniques. Anti-aliasing is basically, you take your jaggy lines and you kind of like put some in-between colors to make them look smoother. I think OpenGL only supported FXAA up until now. It doesn't support TAA still and probably won't. I guess we'll see. But now we have MSAA, which is great, especially for VR games, which is something that matters to me. MSAA is probably the best looking anti-aliasing that you can have in a VR game. Lightmap GI. So Godot supports a whole bunch of different global illumination strategies. There's voxel GI, there's SDF GI, which is, Juan's magnum opus global illumination. And we've had Lightmap GI for Vulkan. Now we can also do that in OpenGL. And that's something I worked on. And also Glow. Bastian did that one. So yeah, the list of things that you can do in the Vulkan renderer, but like just won't work at all in the OpenGL renderer is getting smaller. XR, so the VR, AR, MR stuff. We have a unified system for hand tracking. Previously, every like XR API would have to implement its own hand tracking. So we had OpenXR provided an OpenXR hand node. I had written some code for WebXR that didn't provide a node. It would just give developers access to the raw data or whatever. And I was like, oh, I should probably make a node. But then, we're going to have an OpenXR hand node, a WebXR hand node, and we'll eventually have Apple Vision Pro support. So then we'll have an Apple Vision Pro hand node, and that just kind of gets out of control. So now we have a unified way of dealing with hand tracking data and a single hand tracking node that will work with any of the XR APIs. We have body and face tracking, which is really cool. That's both body and face tracking on headsets themselves, like some of the Meta headsets include different amounts and types of body and face tracking, but also like mocap solutions. So Malcolm Nixon, who did this work, has made plugins to integrate a whole bunch of different companies' mocap technology. And there was some company he was talking to who was considering like making their mocap software in Godot. Which sounds really, really cool. Composition layers are sort of tricky to explain without getting way too into the weeds, but the idea is within Godot, you can make like a flat panel and render your UI on it. But if you instead have the XR compositor do it for you, it can do it at a higher resolution, sharper, probably higher performant when doing those other types of things like sharpening than you could do it yourself. We have support for that now. That was another thing that that I personally worked on. And this isn't actually technically part of Godot. There's a second or separate repo, Godot OpenXR vendors, but where me and Logan and Fredia and Bastian and Malcolm and all the XR people have been adding like special vendor extensions to OpenXR to support like some of the vendor-specific features of the different VR headsets. What's something exciting in there? Well, I don't know. Like on the Quest, you have the pass-through camera that can see your world. There's some specific filtering that the MetaQuest can do. There's the scene understanding, so the Quest has some sensors to understand the room that you're in, and then can use the geometry of your room as part of a game. Like I don't know, put windows in your walls that see out into outer space, or turn your couch into like some sandbags that you hide behind to, you know, shoot in a FPS or something like that. GD extension. You know, in Godot, where there's like the help thing and you can see all of the nodes and classes and their properties and functions and all of that stuff, GD extensions, of course, always could create new classes and nodes that could be used within the Godot editor, but they could not provide documentation. Now they can, which I think will be great for the ecosystem of extensions. Godot does a lot of stuff with virtual methods, like you define a method on your child class and then the parent class calls it. That was something that you weren't able to do in GD extension, but now you can. You can make a GD extension class that declares a virtual method, and then users will attach like a GD script to it, and it can be called from the GD extension. Runtime classes. In the transition from Godot 3 to Godot 4, we had GD native in Godot 3, which worked in a very different way than GD extension in Godot 4. So in GD native was basically like making C++ scripts that you would attach to nodes, whereas GD extension aims to be closer to like actually extending the core engine. And everyone who has been using GD extension to like make engine extensions has been pretty happy with it. It's way better than it was trying to do that in GD native, but all of the people who use GD native to like make the gameplay logic for their class or for their game, like they were making the you know, gameplay scripts, but in C++ or in Python or in Lua or whatever, you know, binding they were using, were not very happy with this change in model. And the two biggest complaints were no hot reloading. If you updated you know, your C++ code, you would have to actually like restart the editor to be able to see like the new properties on your nodes. And we fixed that in Godot 4.2. There's hot reloading for GD extension in Godot 4.2. And the second biggest complaint was all my classes act like tool classes. You know, in GD script, you can make your script be a tool script, which means it runs in the editor, and that's super cool. You can use that to make like extensions to the editor specific to your game that can make like creating levels for your game easier, more efficient, more standardized, whatever you want to do with it. But in GD extension, we didn't have this concept. Everything always acted as if it was a tool class. And so the people who were doing gameplay code were really frustrated that their like game logic was running in the editor. They would have to wrap tons of things with like if checks saying like, if I'm in the editor, don't do any of this stuff. And people were very frustrated. Now we have the idea of runtime classes. So if you register a GD extension class as a runtime class, then it won't run in the editor at all. It will only run in your game. Web stuff. So in Godot 3, all the web builds were single-threaded. In Godot 4, we switched to having multi-threaded web builds, which is actually really great. I mean, there's lots of things you can do with threads. Parts of Godot were written with the idea that we would have multiple threads, but it created a problem that in order to run something that uses WebAssembly that uses threads, you have to set like some specific HTTP headers. Otherwise, it just won't run. And this was frustrating to a lot of people because they would have to learn how to configure their web server, or maybe they couldn't even configure their web server if they were, you know, on someone else's hosting they had no control over. Also, ads. Apparently, like all of the ad networks won't work right if you specify these HTTP headers that enable WebAssembly threads. Of course, nobody likes ads as a user, but they are one monetization strategy for games that has kept some people on Godot 3. So in Godot 4.3, there is now, again, going to be an option for a single-threaded web build. And together with that, something that hasn't been merged yet, but I really, really think it will be merged, we will see, is this samples-based audio. So one of the problems with the single-threaded web build is that there's very frequent stuttering in audio, because the way that Godot's audio subsystem is written is it assumes it's running in another thread, and it's doing like manual mixing of the audio data. And when your game is also doing rendering and physics and game logic, it might not finish those things quick enough to feed some more samples to your audio hardware. So that's why you would get the stuttering. And switching to the single-threaded build in Godot 4.3 brings back the stuttering as well. But Adam Scott has been working on this sample-based audio that uses the browser's like HTML5 APIs to play the audio rather than manually mixing the samples within Godot in C++ land. But it's not merged yet. I really hope it will be, because then we'll get the ease of single-threaded builds, which like are great for game jams or any situation where people are just want to throw something up, but without sacrificing audio. So we already talked about this when I said that MSA, Lightmaps, and Glow are implemented for OpenGL, but the implication there is now you can use them on the web too, because the web can only use OpenGL via WebGL. I mean, one day we'll hopefully have a web GPU backend, and then we'll be able to use like the Vulkan renderer on the web, not really using Vulkan, but using web GPU, which is similar to Vulkan in the same way that we can use Direct 3D and Metal as the backend for those renderers. But yeah, like I love web builds. They're amazing for game jams. And we're getting closer to being able to support all the same things on the web that we could in Godot 3. Some miscellaneous stuff. These two are Linux focused, so if you don't use Linux, this might not be very interesting. But there is now a Wayland display server. So previously, if you used Wayland and you wanted to use Godot, you'd have to use XWayland, which kind of like translates the X11 stuff into Wayland. There's now a direct Wayland backend. There were a ton of bugs in Godot 4 if you used an alternate kind of window manager, like if you weren't using GNOME or KDE. I personally use i3, but like people using like Awesome WM and some of the other weird ones were having all these terrible focus issues. And a ton of work was done on fixing that. My issue in particular is fixed, yay, but so are a whole bunch of other people on their window managers. So the Linux experience is better. And again, none of these bugs, these focus bugs and stuff, existed on Godot 3, so it was one of those remaining like nails that people were getting caught on when trying to switch to Godot 4, and here's another one of them removed. This isn't a very big deal, but I really like it. You can now set up the input map to differentiate between the left and right meta buttons. So like you can have the left shift do something different than the right shift. There are a whole bunch of improvements to the project manager. The UI was reorganized and made a little prettier. I recommend checking it out. FBX is a format that's used really as like the primary format for most other engines for like Unity and Unreal. Godot has focused mostly on the open source GLTF format. We have had the ability to import FBX files for all of the Godot 4 cycle, but it depended on having this extra command line tool installed, the FBX2 GLTF tool. And apparently there were things in FBX files that we weren't importing right, some stuff with materials. I don't know, I've never used an FBX file. But now we have a built into the engine support for FBX using this library called UFBX, which apparently does a much better job. And you don't have to install an external tool. It's built right into the engine. Juan made this enormous interactive music thing that I haven't had the chance to try yet, but the idea is it's like a simplified version of like Fmod or Wwise, which I think is really, really cool. So tons and tons of projects uh, have to, take these proprietary add-ons like Fmod or Wwise to do interactive music. And now if you're doing something that's relatively simple, right, because this isn't a full replacement for those huge suites of software that have whole companies behind them. But if you're doing something relatively simple and want to have interactive music, there's now something built right into the engine to do it. There was a big refactor of animation stuff. I don't entirely understand everything that was done because I'm not super keyed in on animation stuff. And I do know also that this refactor is a prelude to some bigger refactors and bigger changes that the animation team is doing. But you will see some of these things. So the animation player and animation tree class had a lot of duplicate functionality, and also duplicated code. They now have a common ancestor class animation mixer to consolidate that code. There is a new base class skeleton modifier 3D with the idea that like everything that modifies a skeleton in some way, like animates a skeleton, I guess I should say, descends from this skeleton modifier 3D class, and you can now order those, like decide which order each of those things apply to the same skeleton, and also be able to set like blend weights. So previously, if you had two things modify a skeleton, you kind of couldn't predictably say what was going to happen. But now, you can say, okay, I have these 5 things that are going to mess with the skeleton. They're going to go in this order. This one's going to have, 80% weight. This one's going to have 20% weight, and be able to potentially rationally like mix these things together, which is interesting for XR or like anything with avatars. But in my mind, I'm thinking about XR where you might have like the hands driven by hand tracking, but like the arm positions driven by IK, and like the face driven by face tracking. But then maybe you have like a function where you can make your character dance, and so like your legs are actually driven by some handmade animations, and like mixing all that stuff together seems really cool. And that's all the stuff on my list. Yeah. Anybody else heard about any cool new features for Godot 4.3, or have any questions about the stuff that I talked about?
There's a couple of the things I think are that are interesting and that I'm wondering about.
Hmm.
First, there's the single-threaded web build. Has the single-threaded web build been made of the editor itself?
Yeah. Or, good question. So there's a Godot 3 version of the web build, so it must have in Godot 3. I don't know if it's been done for the Godot 4 version, though. Um, that'd be interesting to
Because
check
I
out.
because I remember trying to run the web editor on my Raspberry Pi would cause things to lock up completely, and I'm wondering whether the single-threaded web editor would have that issue. And the
Hmm.
other is that I find interactive music to be intriguing. Like, I'm wondering if, say, I could do use, say, the technique that Metroid 2 uses, where different tracks of the music have different repeat after different amounts of time, creating what the result being something that does not exactly repeat for a very long time. And I'm also
Hmm.
wondering whether it's powerful enough to do a bit of algorithmic music generation.
Yeah, I don't know about the algorithmic music generation, but like the whole idea of the interactive music is that like you don't have like a complete song. Your song is made up of like different phrases that kind of go together, so you can make something that's non-repetitive and something that responds to gameplay. It's really interesting. Like sometimes I'll play a game and not realize it has interactive music until like I put down the controller and like go do something for my kids, and then like I'm just really repeating that one chunk like over and over again now, and then not realizing that it's because the whole thing responds to what I'm doing. But yeah, I'm really excited to see what people do with that.
The Metroid 2 example isn't interactive, but the things that like you have maybe one track with the melody and one with the rhythm, say the rhythm, but and like typically they'd all repeat at the same time. But what Metroid 2 did in a couple late game pieces would have those tracks be different length, so they repeat at different times,
Hmm.
which is something that I don't think I've seen any game do before or since. And so I'm wondering if the interactive music could allow for that to be done.
Yeah, that's interesting. I don't personally know because I haven't had a chance to really play with it, but
Because that definitely seems interesting to me.
hmm.
I actually do have a question about the per vertex lighting, because I know that was ripped out in 4.0, and I know that there's some PRs that are adding some stuff, and I've even played with the PR a few times, seeing that there are some inconsistencies. Are there any changes that with the rendering that could allow that to be a case again?
So I'm not familiar with that work. I guess yeah. I mean, you actually probably know more about it than me if you've already played with that PR.
Okay, for sure.
All right.
This interactive music proposal looks interesting. So I guess you set up transitions, and it can switch between different parts of the piece. So I don't know. Pretty neat stuff.
Yeah. Well, if no one has anything else, thanks so much.